This is 6.07, Part 2. So again, we just went over the mole ratios and to find if we have 3 moles of N2O4 and 6 moles of N2H4, how much water do we get? So just to quickly review, we say the ratio of N2O4 to water is 1 to 4. We use the coefficients from the balanced equation. You start with what you know. We are giving 3 moles of N2O4. What has to go on the bottom of my next fraction? Moles of N2O4 specifically, because on top I have moles of H2O. So I have moles on top and bottom, but it's different because they're of different chemical compounds. Put it in your calculator, and you get 12 moles of water. All right. You can also predict the mass of product you will get when you know the mass of the reactants. So I am going to put these two things in our notes, and so let's go ahead and add those in now. So the first thing that I'm going to take is everything that we did on the whiteboard. So hopefully, like I said, you are writing this down. It doesn't help you if you only listen. You actually have to practice it yourself, and then you'll have these notes to look over later. If you notice, I also tried to color code a few things. Please do not hesitate to color code things as well. That will help you figure things out later as far as where you got stuff from. All right, so the other thing that we're going to do now mathematically is predict the mass of the product you will get when you know the mass of the reactant. So we're going to add some more to it. And that will be our next example that we're going to go through. All right. You can predict the mass of the product you will get when you know the mass of the reactants. I said it 3 times, I know, because you have to keep all these terms straight in your head. So sometimes you got to read things more than once to make sure you're keeping things straight. Chemists need to know the actual amounts of reactants and products for their everyday work. Lithium hydroxide, or LiOH, is used in spacecraft to absorb carbon dioxide, which the astronauts exhale. To make lithium hydroxide, you react lithium nitride with water, and that's the chemical equation. Li3N as a solid plus 3 moles of water as a liquid yields NH3, which is a gas, and 3 moles of LiOH as a liquid. It is important to know the amount of reactants needed to create such a certain amount of LiOH. Take a look at the example to see how it's done. So this is what it looks like up in the spaceship. They have it in canisters. It says scrubbers like these are used in closed rooms and space capsules to scrub carbon dioxide from the air and replace it with oxygen. This canister held by the astronaut is from a space shuttle mission. So it's kind of cool that, well, they don't take up trees with them, right, to convert the carbon dioxide back to oxygen, so they have to use this chemical reaction. Okay. You are given 105 grams of lithium nitride and excess water. How many grams of lithium hydroxide can you make? So first of all, is it balanced? So they drew it out so you can easily see there's 1 blue nitrogen molecule on each side. There's 1, 2, 3 oxygens, 1, 2, 3 lithiums, and 2, 4, 6, 1, 2, 3, 4, 5, 6 hydrogens. All right, then we want to find the mole ratio. Okay, so how many moles of LiN do I have? I have 1. How many moles of water? 3. How many moles of NH3? 1. How many moles of LiOH? 3. Yep, it's the same as the number of molecules because it's the same ratio. That's why it's the same. So it's not the same amount. I could say that there's 3 molecules, 1, 2, 3 molecules, or I could say there's 3 moles because it's 3 times the number of molecules, or 3 times 6.022 times 10 to the 23rd. Different amounts, but the same ratio. All right, so specifically, we are looking in this problem for lithium nitride and lithium hydroxide. And so that ratio, there's 1 mole of lithium nitride that produces 3 moles of lithium hydroxide. So now we want to find the molar mass. So we got to look at our periodic table, and we have Li3N because that's what we started with. Li3N. And so we say, okay, lithium, I have 3 of them. They each weigh 6.941. So my total for lithium is 20.823. Now for nitrogen, I only have 1 nitrogen. Each nitrogen weighs 14, so that total is 14. I add them together, and I get 35 grams per mole. So if I have a mole of Li3N, it's going to weigh 35 grams. All right, so I switched over to our whiteboard, and I want to talk through the steps again because, once again, you just kind of need to practice and repeat these. So when you start out with your problem, I started with 104 grams of lithium nitride. So the very first thing that you want to do is just write it down, okay? Because that tells you where you're going to start. And then you got to think to yourself, okay, what am I trying to get to? I want to get to grams of lithium hydroxide. I can't get there directly, okay? So do you remember what the magic conversion is? If I want to get from one thing to another, I use my magic moles. Okay, I use my magic moles, and am I going to put moles on the top or the bottom of my fraction? Well, remember we need to cancel, so we're going to put grams of Li3N on the bottom so that that unit cancels. And what can I switch it to? I can switch it to moles. But specifically, moles of what? It's moles of Li3N. Okay, so every 1 mole of Li3N weighs how much? That's where we go back to our periodic table. And I say, okay, there are 3 lithiums. They each weigh 6.941. There's 1 nitrogen that weighs 14. I add it together. I get 35 grams for every 1 mole. Okay, now I'm going to keep going. Okay, well, what has to be on the bottom of my next fraction? Well, we need things to cancel, right? So I guess it's got to be moles of Li3N. Okay, and now what am I trying to switch to? What do I want my answer to be about? I want it to be about lithium hydroxide. All right, so that means I'm going to make my top units moles of lithium hydroxide. And what's my mole to mole ratio? Here's where the ratio comes in. Well, I have 1 lithium nitride for every how many lithium hydroxides? 3. Okay, now I checked that I canceled off my previous units. Yes, I did. Yes, I did. Okay, what has to go on the bottom of my next fraction? Well, again, it's all about canceling, so it has to be moles, but specifically moles of LiOH. And what am I trying to get to? Grams. Grams of LiOH. So if I have 1 mole of LiOH, now I have to look at my periodic table and add how many grams that. Okay, so let's add it up. I have 1 lithium, 1 hydrogen, 1 oxygen. So I have 7 plus 1 plus 16 gives me a total of 24 grams of lithium hydroxide for every 1 mole of lithium oxide. Now I put it in my calculator. When you put it in your calculator, you multiply everything across top. So 105 times 1 times 3 times 24. Okay, so put that in your calculator, and then you're going to divide by 35. When you do that, you get an answer of 216. But 216 what? Well, this canceled off, So the only unit we have left, and yes, you need units in your answer, is 216 grams specifically of lithium hydroxide. Now, when the lessons did this, they did the exact same thing that we did in that they found the mole ratio. So again, mole ratio 1 to 3. And then they said find your molar mass. And then they figured out how many moles of lithium, how many moles of lithium hydroxide were the equivalent based on your ratio, and then the mass. So if you want, you can do it step by step by step. Personally, I find it easier to just kind of list everything out in one big, huge row because it helps me remember what comes next. Because I know my grams have to cancel. Then I'm stuck. Okay, so I go to my magic moles. All right, I have moles. Okay, I can do my mole to mole ratio. This mole to mole ratio is magic. It's how you convert from one chemical to a different chemical. So mole to mole ratio, then I have moles on the bottom, grams on the top, I'm done. So it's simply a matter of canceling things out. When you get stuck, go to your magic moles, do a magic mole ratio, and that's how you get to your next chemical. So again, you should have written this down in your notes, otherwise do a little screenshot like I'm doing here to make sure that you have it in your notes. And there you go. I'm also going to add the hint. Hint, moles are magic. So when you get stuck, what do you go to? Convert to moles. Use the mole ratio to do what? To change from one chemical to another chemical. Okay? Very important to remember your magic mole ratio. Reactants are often limited. In any chemical reaction, there are reactants and there are products. For a reaction to start, the reactants, often called reagents, have to be mixed or at least come in contact with each other. As soon as the reaction starts, reactants begin to get used up and products begin to form. But when does this reaction stop? The reaction must stop as soon as one of the reactants runs out. The first reactant to run out is called the limiting reactant or limiting reagent. So again, the one that you run out of, it causes you to stop. It limits your reaction, and it's your limiting reagent or limiting reactant. So again, we saw this before. We have just a tiny little bit of water. We put it in. It causes the tablet to shrink because it's reacting and forming the product of those bubbles, probably carbon dioxide. And then you're done because you ran out of water. Water is your limiting reagent. You can determine amounts you need. To determine which reagent is the limiting reagent, consider these steps. Number 1, convert quantities of each reagent to quantities of moles. Told you, they're magic. Determine how many moles of product can be produced from each reagent, assuming there's excess of every other reagent. Step 3, multiply the appropriate mole ratio. Step 4, the reactant that will produce the least amount of product in moles is the limiting reagent and will run out first. For example, if an astronaut exhales 20 moles of carbon dioxide per day, how many grams of lithium hydroxide will be needed to remove it from the spacecraft? And we will continue this problem on the next recording because again, I get cut off after 15 minutes. So we'll continue on the next one.